Okay, on problem number 1, we notice that the A value is 2, our B value is 3, and since B is more than 1, we have exponential growth. The y-intercept is whenever we plug in 0 for x, and in this case we get out 3 to the 0 is 1, and 1 times 2 is 2. So we can plot that, 0, 2, and our asymptote is the k value, which is 0. So the x-axis is our asymptote. Now, in order to create our function table, we can simply use the calculator, and you're going to go to table, and you're going to type your equation in. And we had 2 times 3 raised to the x, and your x variable is right there. Then you're going to click enter, and our start button, we really want to start at -2 since that was the first x value, and then we're going to click enter, we get OK, and notice when we get to enter, you have your function table. So at -2 we have 2 9ths, and then you can just use your arrow button to scroll down. So let's input that. So at -2 we had 2 9ths. At -1 we had 2/3. And then we had 0, 2, and then we had 6, and then we had 18. So as you can see, these are going up times 3, which is the b value, our multiplier. So now let's plot these, and we have -2, 2 9ths, and then we have -2/3, -1, 2/3, 0, 2, and then 1, 1x is 1, y is 6, and 1x is 2. We have 18, and our exponential growth. And now we can finish out our key features. All x values, all real numbers. The least value, the range is 0, but not touching 0, so we have parentheses, and then that continues forever. Up, intervals of increase, all real numbers. Intervals of decrease, there are no x values that cause this graph to decrease in behavior. As x approaches negative infinity, f of x is getting closer to 0. And then as x approaches positive infinity, our output continues forever increasing. Our AROCs, we want to know the average rate of change between 0 and 2. So we're going to find the slope of the secant line. And luckily for us, we have those values in our function table. So we have the 2 points, 0, 2, and 2, 18. If we did not, we would plug in the 0 for x and get out y, and plug in 2 for x and get out y. So the 2 points are 0, 2, and 2, 18. So AROC, the change of the y's compared to the change of the x values, and that gives us 16/2, which is 8. Number 2, let's get a different color. This time our A is 3, but our B is 1/2, so we know this is a decay because it's between 0 and 1. Our y-intercept is 0, 3. And the asymptote is y equals 0, again the k value, which is 0. Let's use our graphing calculator, or our scientific calculator, and this time we're going to clear it. So we're going to go to secant 0, 2, that clears out the memory. Go back to your table, put in your equation, 3 over 2 raised to x. We're going to click enter. Again, we want to start at -2, enter, enter. And our table of values are 12, 6, 3, 3 halves, and 3 fourths. So we have 12, 6, 3, 3 halves, and 3 fourths. So we're going to plot those. So at -2, we have 12. -1 is 6. 0, 3. 3 halves is the same as 1.5. So we go over 1 and up 1.5. And then 3 fourths is about right here. Now let's sketch in the asymptote always and label it. So this time it is an exponential decay, getting closer and closer to the asymptote, but not touching. Domain, any x, we can have any value for x. Our range, it goes down to 0 without touching, and then goes forever up. Intervals of increase, there are no x values that cause this to increase, and any x value will cause it to decrease. In behavior, this time as x approaches -infinity, my f of x goes up. As we go to the right of the graph, toward positive infinity, the end behavior approaches 0. Our AROC, we have those two ordered pairs in our table. We could also do it from a graph if we wanted to. So let's try that. So at -2, we have 12, and at 0, we have 3. Draw the secant line. And our rise over run, we're going to go down 1, 2, 3, 4, 5, 6, 7, 8, 9. And we're going to go over 1, 2 to the right. So -9 over 2.